At the heart of programming is the concept of repeating a task multiple times. For loops are one of the most fundamental ways to do that. In this lesson, we're going to introduce ourselves to for loops in Python, so let's get started. So we start by opening up a new Google Colab notebook, and I'm going to call this one for loops. So here is our list of learning objectives. If you like, you can pause the video and read through these, but we're going to come back to them at the end of the lesson. Let me click this icon here at the top to toggle the header visibility so we have a bit more space. And let's open up now a new text section and call it imports. And then beneath that, we'll open a new code section and import some libraries. I'm going to import pandas as PD. I'm going to import Plotly Express, which we'll use at the end of the lesson as PX. And for practice dataset, I'm going to import the Vega datasets library, specifically the data submodule of that. So type these 3 lines of code and press Command or Control Enter to run those. And now I open a new text section and call it Intro to For Loops. And let's start with a very simple example of what for loops let us do. So imagine we have a list of ages like this. Ages equals list 7, 8, 9. And we want to convert these ages, which are in years, to months. One thing you could try doing is you multiply the years times 12 to give you the years in months. And let's try that and see what happens. So as you can see, it doesn't actually multiply these to months. What it rather does is it reproduces the list 7, 8, 9 12 times, which is not what we want. So let's close this output, clear selected outputs, and say this does not work to convert to months. So one thing we can do to convert to months is to use a for loop. And so we're going to write now our very first for loop. I'm going to open a new code chunk and type along with me. I'm going to say the following: for age in ages, and then a colon. And then I press enter to go to the next line. And you see that Google Colab has automatically indented the next line for me. So because of that colon, the next line is automatically indented. And that is correct. We want it to be indented. And in that next line, I'm going to do the following: print age times 12. And if we run this now, we have now been successful in the conversion. So 7 years is 84 months, 8 years is 96 months, and 9 years is 108 months. So let's think through the syntax here. So for and in are special keywords that create that loop. We also need this colon, and we also need that indentation for the next line. This word here, age, is just a placeholder for each iterator, for each value of the ages list. So we could use anything here in place of age. We don't have to use age. So for example, I could say for random name, and type this along with me as well. For random name in ages, I could say print random name. So let's run just that. So now we're printing each element of ages, and we gave each element the value random name, or the variable or iterator random name. And then I can also do print random name times 12 to implement our conversion. Now, one thing to note is that the print statement here is mandatory, because normally in Google Colab, you don't always need print statements. As an example, if I just type ages here and I press enter, I don't need to type print ages in order to print it. It prints automatically. But inside of a for loop, that automatic printing does not work. So you have to type print. So as an example, let me copy this, put it in this line. And if I remove the print statement, the loop will still work. So it has still internally multiplied age times 12, or each age times 12, but it doesn't show you the output. So you need to wrap that in a print for the outputs to be visible. Now with those essentials in hand, try the following practice question. Practice, let's call it an hours 2 minutes loop. Hours 2 minutes loop. And what I want you to do is use a for loop to convert this list of hours to minutes. And here's your list for you. Hours equals 3, 4, 5. So write a for loop similar to this one to convert this into minutes and print the output. Pause the video and try that out. Next, let's open a new text section and call it printing with f strings. So f-strings, which I think stands for formatted strings, is a way to combine variables and strings together. You'll see what I mean by that in a minute. Let me grab this existing for loop and I paste it there. And imagine that instead of just printing the output of the months here, we wanted a more structured output. We want to print something like 7 years is 84 months, 8 years is 96 months, and so on. How could we do that? One way we could try to do that is use the plus operator to concatenate things together. So let's try that. I'm going to type the following. I type age plus years is plus age times 12 plus months. Okay. And before I start to run and debug this, let me just quickly remind you of what the plus operator does in this case. If we have any two strings, for example, let's say first name equals Kene and last name equals Nuosu. You don't have to type this. It's just a reminder. We can combine those two strings with first name plus last name, and they get concatenated that way. If we put a space before the last name, then they get concatenated with a space. And we don't even need to pre-assign these variables. We could just directly say Kene plus Nuosu. Whoops, Kene plus Nuosu. And that also gives you the same output. So that's what we're trying to do here. We're trying to combine each age, 789 for age, with the value in months. And let's see if this line of code is going to work. So I'll tell you it's not going to work for a number of reasons. So from the type error, we can see that we can't have both an integer, int type, and a string type, concatenated with plus. So we have to convert these integers into strings. So we're going to wrap them in str to convert to a string. So convert string age there and string age times 12. And now if I run this, we should have the right output. Okay, but we're missing some spaces. So let's add a space here and a space there maybe. And I think we need one more space, a space after the years is. All right, so that looks good. So pause the video, make sure that you understand this. To help you understand it a little bit better, let me pull in the ages vector or the ages list from the start so that you can see it again. So what's happening is first we have age set to 7. We convert that to a string so we can use the plus sign. So we say 7 years is, and then 7 times 12 months. Then we go to the next step of the loop, 8. 8 years is 8 times 12 months, and so on and so forth. So this is one way to get this nice structured printed output. Another way is to use f-strings. So now we're going to move over to f-strings. So let's open a new code chunk and see how to use an f-string. So I'm going to say for age in ages again, and then I'll say print, and then the keyword f, or the key letter f, and then I'm going to open up a string. Now within this string, anything that I wrap in curly braces like this is going to reference some external variable. So I could start by saying print age and then years. So what this does is printing each age in that list. And now I can extend this and say is age times 12 months. So hopefully you can see now that f-strings are a much more concise and compact way to do this kind of string concatenation. Okay, so that's a very simple concept, but there's many different syntactic elements that you have to pay attention to. So try to practice that. Here's a practice question for you. Practice. And I'm going to say, again, convert this list of hours below 2 minutes, but use f-strings to print both the original hours and the converted minutes. Let me define that list again for you. Hours equals 3, 4, 5. And here's an example outputs that I want you to have. You should have something like 3 hours is 180 minutes. So pause the video and try that out. Okay, let's take a quick detour and ask ourselves the following question. Are for loops useful in Python? So for this, I'm going to open a new text section and call it Are for loops useful in Python? The reason I ask this question is that there are many cases in Python, especially when we're doing data analysis, where for loops are not the ideal way to do an operation. That is, most structures in data analysis allow us to do this thing of repeating a task multiple times without using a for loop. Let me just quickly remind you of such things. So instead of ages as a list, we could create ages as a series. So let's call this variable ages series and define it as a pandas series with values 7, 8, 9. And now the series, if I print it, it starts to behave a little bit more like a column in an Excel data frame. So it's easy to apply some formula to it, like for example, multiplying by 12, and that will be operated across the whole column. So let's try that, ages series times 12. And that works just immediately. And indeed, most of the time in data analysis, you'll be working with such structures that don't necessarily need loops in order to iterate. However, while libraries like pandas give you multiple options for iterating over code, there are many cases where you still need to use for loops. So let's summarize that in a quick text section. I'm going to say while libraries like pandas give us easy ways to iterate over an action without loops, loops are still useful in many cases. And then one example, which we will see below, is for making multiple plots. For now, let's end our side quest and let's talk about looping with Enumerate. So I'm opening a new text section and I'm going to call it looping with Enumerate. So what Enumerate does is it lets us access both the index and the value for whatever structure we are iterating over. What does that mean? Let's see. So again, we define our list, ages 7, 8, 9. It's already defined from before, but we're just doing it again so we can easily view it here. And now let's see how we can use Enumerate to iterate over this. So I'm going to say for item in Enumerate. And remember, this is just a random keyword. We could have used anything, but in this case, I'm using item. So for item in Enumerate ages, so the structure we're trying to iterate over is ages. So we put that there. We put our colon, you press enter, and let's print each of those items. Print item. So what this is printing for us now is both the index of each of those values, 0, 1, 2, and the values themselves, 7, 8, 9. To make this super clear, let me change 7, 8, 9 to actual text. So 7 there, 8, 9. We'll bring it back to numbers in a second. So 7, 8, 9, and let's print it now. So now we see we have the index, 0, 1, 2, and the values in the list, 7, 8, 9. And now instead of accessing the item as a whole here, we could instead access the index and the value of each iteration separately. So let me show you what I mean. Let's open a new code chunk. We'll copy this so we can start from there. And instead of accessing the item, I could say for index, comma, age. And then I'm going to print the index and the age. Print index and age, index and age. And so this gives us both the index and the age, but it doesn't look that different from our original there. It will look different now if we format it nicely with an F string. So let's go F and let's type the person at index, and let's put index as a variable inside of curly braces, is aged, and let's put their age there. And now we have a nicely printed statement saying the index for each of those enumerated ages and the age. As a reminder, again, each of these things here is a completely random name. So I could say for rando and rando1, the person at index rando, where rando stands for random, is aged rando1. Okay, and that gives you the same output. So the first variable before the comma is the index, and the second variable after the comma is going to be the value. But I put index and age back because those are more reasonable names. However, ages is not a random name. Okay, ages is referring to the ages list that we created up there. Let's try to put it all together now to get a statement like the following. I want a statement like this. The person at index, sorry, this should be at index 0 is age 7 in years, which is 84 in months. And we want that for all three elements of the list. So let's see how we can do this. I'm going to copy this existing loop. Let's copy that, paste it in this chunk. And I'm just going to add in the ages and months part. This I think you should be able to do on your own. So if you want, you can pause the video and practice it. But I'll go ahead nonetheless. So the person at index dash is age dash in years, which is age times 12 in months, age times 12 in months. So very good. Now we've seen how to use enumerate. We've seen how to access both the index and the value from enumerate. And we've combined that with f strings. So now it's time for your practice question. So I say practice, use enumerate and f strings to print a sentence for each hour in the following list, in this list. Again, it's the same list, hours 345. And here's an example output. I want you to have something like index 0 is 3 hours, which is 180 minutes. But that should be repeated 3 times, of course. So pause the video and try that out. So now we have an understanding of the very basics of for loops. Let's see how we can apply that to a real-world problem, which is going to be generating multiple plots. So I open a new text section, and I call it a real loops application, generating multiple plots. And for this, we're going to use the Gapminder dataset from the Vega datasets library. So in order to access that, I'm just going to define something called Gapminder, a variable called Gapminder. We grab it from the data submodule of Vega datasets, which we imported at the beginning, if you remember. And let's view the head of that. So Gapminder.head. So as you can see, we're going to have a country with some statistics about that country for a number of years. And there are many countries in this data set, over 100, I believe. So what we're going to try to do is create a line chart showing the life expectancy for specific countries using a for loop. Generally, when you want to write a complex for loop, you start by writing a single iteration of that loop. That is, you walk through the task as though you were going to do it for only one value, and then you plug that into a loop and turn it into loop-like code. So let's see what I mean. So I open a new code section. And first, I'm going to filter this to just China. And we haven't really taught you how to filter yet, but just type along with me, and we'll get to this later in the course. So I type gapminder.query, and then in quotes, I'm going to grab the country variable or the country column and check for when that is equal to China. And notice here we have nested quotes, the quotes outside to define the query, and then the quotes inside to define China. And we don't need that space there. And let's print the China data after this so we can see what's inside of it. So now we have just the rows for China, and we can plot a line chart showing life expectancy over time with Plotly Express. So I'm going to say px.line, and you can see all of the different arguments. The first one is data frame, so I can write data frame equals China data. Or I could just type China data, since that's always the first one. That's always the first argument, and that's my preferred way. So China data, and then x equals year, and year has to be in quotes. Y equals life expectancy. I wish this pop-up would go away. Life expectancy, or rather life expect, I think, is the name of the variable in the data set. Let's see. Yes, life expect. And let's give it a title. Title equals life expectancy in China. All right, let's run all of this. And now we can see the life expectancy over time in China. You can see there was a big dip around 1960. So as some history research, you can find out what exactly happened around 1960 that caused this huge dip in life expectancy for China. So what we have done is we have written the code to make this kind of plot for a single country. Now let's see how we can write the code to make the plot for multiple countries. So I'm going to hide these outputs so I can see my single country code easily. And now I'm going to write the multi-country code. So the first thing I do is define some kind of list of the countries I want. In my case, I'm going to do one for the 5 biggest countries, which are India, China, the United States, make sure that that's capitalized, Indonesia, and then Nigeria. And now let's write our loop. So I'm going to say for each country, and I'll call that country name, for country name in countries, colon. So first I want to filter to just that country's data. So country data. So here I did China data, but in this case, it's going to be a loop. So the country is going to be changing each time. So country data equals, and I'll copy this code, gapminder.query. And instead of querying for just China, I need a way to query for each particular country name. The way I can do that is I'll remove all of this. And within the query, I type the @ keyword or the @ key symbol, and then I put country name in there. Okay. You'll become much more familiar with this syntax when we look at pandas. But actually, since we're here, let me just quickly demo that for you in a code chunk up here. So I'm going to just call this my country. My country is equal to Nigeria. And I can access that variable inside of the query. So country double equals @ my country. And now I can print my country's data there. Let's call this my country data. My country data. And as you can see, this now filters for just Nigeria. So this @ keyword lets you access external variables within the query. Oops. And it looks like I have some unexpected indentation here. So let's get rid of that. Okay, so that's a quick demo of this @ country name thing. So here, country name is going to be first India, then China, then United States. And each time we're going to filter for that country name. And now, just like we use China data to plot a line chart, we're going to use this country data to plot a line chart. So let's grab this code, put it here. And it's getting a bit hard to read, so let's press enter after each comma in order to put those on new lines. And instead of China data here, of course, we should be using country data. And now how do we change the name China in the title? Think about it. We can use F strings. So I'm going to type F here. And instead of China, I'll access the country name. So let's grab country name and put that in braces over there. And now we're almost done. Technically, if we run this, the code actually runs, so the code is fine, but we don't see any plots. The reason you don't see any plots is you have to explicitly print or show the output whenever it's within a loop. And the way we can explicitly print or show the output for Plotly Express is with the show method. So first we have to assign this into a variable. In my case, I'll just call it fig. And then on a new line, I'll type fig.show. And that, ladies and gentlemen, is our complete example of how to use a for loop. Let's run this. And we can see now that we have a plot for Indonesia, a plot for Nigeria, a plot for the United States, and so on and so forth. Okay, that's a very large piece of scary code. So I want you to do 2 practice questions. So the first practice question, I'll call this one population over time. And what I want you to do is use the Gapminder dataset. Use again the Gapminder dataset to create a bar chart and use px.bar for that of the population over time. Population over time for the United States, Canada, Mexico, and Jamaica. Okay, so do those North American countries and plot their population over time. All right, and here is another practice question for you. In this one, you're going to be using the tips dataset. So let's call it practice. Histogram, tips histogram by day. And here I want you to use the tips dataset to create a histogram of the total bill for each day of the week. And let me remind you how to get the tips dataset out of the Plotly library. So let's call it tips. And we grab it from Plotly, px .data.tips. And let's print that so you can see that dataset. So here's tips. And as you can see, there's a total bill column. And there's also a day column. So I want you to do a histogram of total bill for each day. And because there's only 4 days, let me just quickly define the list of days that you're going to use so you don't get confused. Later, we'll show you how to extract all the unique days. But for now, just do the following. fry, sat, and sun. Fry, sat, and sun. So iterate over this list of days to create those histograms. So that's the end of our brief intro to for loops. Let's go through our learning objectives. So now by the end of this lesson, you're hopefully able to use basic for loops in Python. Use enumerate to iterate through lists in a loop. So hopefully you remember the enumerate function there. Now you can also use f-strings to format output within loops. And finally, you can apply loops to generate multiple plots for data visualization. So congratulations, you have covered the basics of for loops, from understanding the syntax to actually applying it to a visualization practice question. As you progress in the course, you will run into many more examples of ways to use loops in Python. So that's it from me for today. I'll see you in a future video. Bye-bye.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.